Look up at the night sky. You see stars, countless points of light, each a sun like our own. For thousands of years humans have wondered, what's out there? Are we alone? Curiosity is part of what makes us human. We are explorers by nature. We've climbed mountains, crossed oceans, and now we look to the stars. We build robotic explorers, machines that become our eyes and ears in the cosmos. Launching a probe into deep space is an act of optimism, a statement of faith in the future. They travel through the cold, dark vacuum of space, facing the vast emptiness between worlds. Every discovery brings us closer to understanding our place in the universe. This is why we explore. What is a space probe? Think of it as a robot scientist, an unmanned spacecraft built to gather information from places humans can't yet reach. Probes travel for decades, withstand harsh environments, and don't need food, water, or air, just power and instructions. Each probe is custom built for its mission, packed with the right tools for the journey. Most have a power source, often a radioisotope thermoelectric generator, RTG, for long missions far from the sun. They have antennas to send data back to Earth and receive commands, and a suite of scientific instruments, cameras, spectrometers, magnetometers. Probes are fact-finding machines, our extension into the cosmos. Some fly by planets, snapping pictures and taking measurements. Others orbit for years or even land and explore the surface. Each mission type answers different questions, giving us a fuller picture of our cosmic neighborhood. These robotic explorers are sophisticated, with onboard computers and thrusters for course corrections. They must be incredibly reliable. There's no mechanic millions of miles from home. Engineers designed them to survive the ultimate journey into the unknown. A space probe is more than a machine. It's a masterpiece of engineering and a symbol of human curiosity. Every probe is a leap of faith, sent to places we can only imagine. They are our messengers, bringing the universe a little closer to home. Through them, we explore the cosmos. Two legendary probes, Voyager 1 and Voyager 2, were launched in 1977, taking advantage of a rare planetary alignment. This alignment, occurring only once every 176 years, allowed a spacecraft to use gravity assists to visit multiple outer planets. The mission, called the Grand Tour, aimed to explore Jupiter and Saturn, with the possibility of going further. The probes were packed with cameras, sensors, and instruments to study planets, moons, atmospheres, and magnetic fields. Voyager 2 launched first, followed by Voyager 1 on a faster path. Voyager 1 would reach Jupiter and Saturn first. Voyager 2's route allowed it to continue to Uranus and Neptune. This dual-path strategy was a stroke of genius, maximizing the mission's potential. On board each Voyager is a golden record, a time capsule with images, greetings in 55 languages, sounds of Earth, and music from Bach to Chuck Berry. It's a message to any extraterrestrial civilization. This is who we are. The launch of the Voyagers was a moment of hope and ambition, marking humanity's boldest journey yet. These probes were built to last, ready to rewrite our understanding of the solar system. The golden record is a beautiful gesture, a cosmic greeting from a small planet with big dreams. Voyager's mission was more than science, it was a statement of who we are and what we aspire to be. The Voyagers became our most distant explorers, carrying our story into the unknown. Their journey is a testament to human ingenuity and imagination. They are not just machines, they are symbols of our desire to reach beyond. The Voyager twins set out to explore, discover, and inspire. Their legacy continues to shape our quest for knowledge. They are humanity's ambassadors to the stars. The Voyager probe's first stops were Jupiter and Saturn, the giants of our solar system. They sent back stunning images revealing Jupiter's Great Red Spot as a swirling storm and its atmosphere as dynamic and violent. On Io, they discovered active volcanoes, the first seen beyond Earth. Europa's cracked, icy surface hinted at a hidden ocean. At Saturn, the probes revealed the ring's intricate structure, thousands of ringlets, mysterious spokes, and shepherd moons. Titan, Saturn's largest moon, was found to have a thick, hazy atmosphere rich in nitrogen and methane. Voyager's discoveries transformed our view of the outer planets, showing a solar system far more dynamic and diverse than we imagined. These encounters sparked decades of fascination and inspired future missions. The images and data changed textbooks in our understanding of planetary science. The Voyagers gave us a new solar system, alive with storms, volcanoes, and mysteries. After Saturn, Voyager 1 headed for interstellar space, But Voyager 2 continued the grand tour to Uranus and Neptune. In 1986, Voyager 2 became the only spacecraft to visit Uranus, discovering its extreme tilt, faint rings, and 11 new moons. Uranus's magnetic field was found to be off-center and oddly tilted, hinting at a slushy, icy interior. The brief flyby raised more questions than answers, revealing a truly bizarre world. In 1989, Voyager 2 reached Neptune, a vibrant blue planet with raging storms and the fastest winds in the solar system. The Great Dark Spot and high-speed methane clouds showed Neptune was far more dynamic than expected. Voyager's quick glimpses of these ice giants provided the foundation for everything we know about them. The grand tour ended with a stunning portrait of the solar system's most distant worlds. These encounters revealed the outer planets as places of wonder and surprise. Traveling to the outer solar system is a monumental challenge. Distances are immense. Probes get a huge initial boost from powerful rockets, but that's just the beginning. The real secret is gravity assist. Flying close to a planet like Jupiter, the probe is slingshotted onward, gaining speed without extra fuel. This maneuver saves years of travel time and vast amounts of fuel. Far from the sun, solar panels are useless. So, probes use radioisotope thermoelectric generators, RTGs, nuclear batteries that provide steady power for decades. Communicating across billions of miles is another feat. The Voyagers use large dish antennas to send faint radio signals back to Earth. These signals are picked up by the Deep Space Network, giant antennas in California, Spain, and Australia. This global network ensures we stay in touch with our distant explorers. Every aspect of deep space travel is a triumph of engineering and ingenuity. Gravity assists, RTGs, and the Deep Space Network make these epic journeys possible. Without these innovations, the outer planets would remain forever out of reach. Our probes are proof that with creativity we can explore even the most distant frontiers. Leaving the solar system isn't just passing Neptune. It means crossing the sun's vast bubble, the heliosphere. The heliosphere is created by the solar wind, a stream of charged particles that forms a protective bubble around our solar system. The first boundary is the termination shock, where the solar wind slows as it meets interstellar space. Voyager 1 crossed this in 2004, Voyager 2 in 2007, a major milestone. Beyond lies the heliosheath, a turbulent region where the solar wind collides with the interstellar medium. The final boundary is the heliopause, the true edge of the sun's influence. In 2012, Voyager 1 crossed the heliopause, becoming the first human-made object in interstellar space. Voyager 2 followed in 2018, confirming the achievement from a different location. These crossings marked humanity's entry into the galaxy beyond our sun. The Voyagers are now true interstellar travelers sailing the cosmic sea. Their journey redefines what it means to leave home. Now in interstellar space, the Voyagers are sampling the environment between the stars for the first time. They measure plasma, magnetic fields, and cosmic rays, data we could never get from inside the heliosphere. Galactic cosmic rays, accelerated by distant supernova, are now measured directly, helping us understand the radiation environment of the galaxy. This knowledge is vital for planning future human missions beyond the solar system. The probes also measure the density and temperature of the interstellar medium, the raw material for new stars and planets. Voyager data revealed the interstellar plasma is denser than expected and mapped the local magnetic field. Even as their power fades, the Voyagers send back precious data, postcards from a place no human has ever been. They help us understand the shape of our heliosphere and how our solar system interacts with the galaxy. These missions are pure exploration, venturing into the unknown and returning with wonders. The Voyagers' discoveries continue to surprise and inspire. The Voyager story is just the beginning. Future interstellar probes will be faster, smarter, and more capable. New propulsion ideas like giant solar sails or advanced nuclear systems could send probes to other stars within a human lifetime. Imagine a probe reaching Proxima Centauri, taking pictures of its exoplanet and searching for signs of life. The ultimate goal to find out if we are alone in the universe. The legacy of Voyager is not just data, but inspiration. These missions show what humanity can achieve when we dream big and work together. They expand our perspective and remind us of our place in the cosmos. The journey to the stars will be long, but it's a journey we must take. The universe is waiting to be explored. The next chapter in our adventure is just beginning.